Okay, we'll try this again. Otherwise, I'm back in the room, class, back in the back of the room. No, it wasn't on. There we go. We're good. Equals, we said the first term plus 4 times n minus 1. Good. Let's go ahead and continue that with distributive property and all that. So distribute the 4n. We have 2 plus 4n minus 4. And so we're going to be used to seeing it as 4n minus 2 or negative 2 plus 4n. Doesn't matter. The other part of this is to recognize it in function notation, so using f of whatever. Since we're using n, here's how we'll write it. F of n equals 4n minus 2. So nothing changed other than that's called function notation. Okay, our domain in this sequence. Unfortunately, it's not all real numbers because this is like saying your y values. Your x values would be saying the first term is 2, the second term is 6, the third term is 10. So that's your x values, your domain. So how can we rate that? Could it be 1.5? No, can't be 2.5. So I asked you like you would know. You probably don't know how to write that. This is how we would phrase it. N is an integer because integer means no decimals. And we also add it and greater than or equal to 0. You write that for the domain. So we don't have our 0 term, but you could. That's why, even though the 0 term isn't written, you could figure it out that it's minus 4, negative 2. So technically you could have a 0 term, even though it's not written here. And by it saying an integer, it says it can't be decimals. That's what integer means. No, because you can't, with sequences, you have to think of it as starting at 0 or 1, not negative. Good question. So no, you cannot have negative. And then what type of function is represented by it? This is a linear function, a line. Yeah, Grace. So the sequence itself doesn't matter. It's the starting that because that your x values are like this is term 1, term 2. You see what I mean? And technically we've learned how to go backwards to 0, but we never go to the negative. Well, let's see in different scenarios. You're gonna see why it's not always, but we'll apply it to the scenarios. It'll make sense to you in the scenarios. So let's read our first scenario. It says, Jenna wants to make mittens for her classmates. She buys a new sewing machine, which costs $20. The cost of the material for each pair of mittens is 50 cents. Write a function for the cost as a function of the number of mittens Jenna makes. What is the domain? So it tells us write a function for the cost. That's going to be our y equals, or in this case, c. When we are writing it in function notation, we want to choose another variable with it. It could be n like we did above. It could be x. We could use m for mittens. What do you guys want to use? What letter? M for mittens. C parentheses m for mittens. All right. So what's the constant? What's always there in the equation? The $20. You start by buying a sewing machine for $20. Plus what? And then it's 50 cents per mitten. So I would put 0.50 m. because the 20 is being added regardless. She buys a new sewing machine, costs 20. So regardless, she's already paying 20 bucks. The cost for the materials for each pair is 50 cents. It's 50 cents for each pair of mittens. 20 bucks was standard. 50 cents is what each mitten will cost. Okay, so now let's think about our domain here. Could she have had 0 mittens? Yeah, she could have had 0 mittens. Could she have had half a mitten? No. So it's going to be the same idea for your domain. We'll say m is an integer and m is greater than or equal to 0. Now, in number 2, your domain will not be the same as 1. Let's see why. Ethan is buying some chicken. Do we like chicken in here? Yeah. Okay, cool. Good question. Do we like fish? I love fish. Yeah. I love sushi. Sushi's my fave. Okay. Ethan is buying chicken at the deli. Chicken costs $2.99 per pound. Write a function for the cost of the chicken. C as a function of the number of pounds Ethan buys. What is the domain? So again, it wants us C. Now, I wouldn't use chicken again because that would be another C. So what's another variable we could use to represent chicken? X, L, and what? Fried chicken. I don't know. Let's just use X. Let's not. I don't use X. You guys can decide. Equals. Did we have a starting amount for the chicken? No, it just depends on the pound. 2.99x. Now here's why our domain is different. You can have half a pound. You can have 0.1 of a pound. You can have 2.5 pounds. Now, can you have negative pounds? No, so it's not all real numbers. You could technically have 0 pounds though, because that would be not buying a chicken. So we would say, if you want, you can use interval or the inequalities. X is greater than or equal to 0. I don't have to say that statement though, because you're able to have a decimal for your chicken pound, for your pounds. You can also write it in bracket 0 infinity if you wanted to. It's the same thing. I would suggest not doing that for example 1. Well, I guess it doesn't matter as long as you have m as an integer, and then you could write it like that, I guess. That's fine. But you have to specify in example 1, it has to be an integer, versus here, it could be anything. All right. Go ahead and try this question. This is from AP Classroom, so it's not too hard of a question. Oh, yes. I'm assuming they used, no, the cost of the shovel as S dollars. Yeah. Cost of one plant is P dollars. What could we eliminate right away? B and D. Good. We didn't do exponents. These are constants. All right. You guys think it's A or C? A. Only because we're following the function notation. If you guys take a look at C sub n, that's not in that function notation. I actually only realized C could, yeah, no, it's, why is it A over C? No, because it wants function notation. See, I had to second guess myself. Now I'm second guessing myself. No, but it is A. Linear versus arithmetic. Yeah. What were you saying, Michael? What were you saying? Nothing. Okay. Now here's when we're gonna have to think a bit harder now. So this is the fun part of this lesson, kind of applying yesterday's and thinking a little outside of the box. So if an arithmetic sequence has the terms a sub 2 equals 47 and a sub 14 equals 179, write a general formula for the sequence. But we need to find D first, or difference first. Now, yesterday, we practiced writing an arithmetic sequence and in slope-intercept form. What was the difference? What did the D represent in slope-intercept form? Anyone remember? Slope. It represented our M. Good. So our difference represented the M in mx plus b. So slope. So we need to find our D first. So let's think about this as a point, 247. And we'll think about that as 14,179. And then we can use slope that way. So our D, aka our M, is y2 minus y1 over x2 minus x1. 179 minus 47 over 14 minus 2. You get 132 divided by 12, which is 11. So that's our D, or our M. We'll use, they wanted us to find it as D. That's our D. Okay, that's part one. We found the D. Now we need to find the formula for the sequence. So to do that, we can choose either point. You can choose this or this. In fact, I'm going to show you, well, later on, okay, we're going to show it both ways here. So, in fact, if we're going to use the a sub n equals a1 plus c times n minus 1, remember yesterday I told us we can also see it as a sub n equals your second term plus d times n minus 2. Or you could use the 14th term times n minus 4, 14. So why don't we use this? Because we have the second term, 47. So we'll say a sub n equals, oh, you know what? I just realized this is all part of the same question. You could get, there's more space for you down here. Sorry. Here, I'll write it again over here. So we can say our second term, which is 47, plus our d, which is 11, times n minus 2. (47) plus 11n minus 22. So a sub n equals 25 plus 11n. Do you think if we used the 14th term and did n minus 14, do you think you'll have the same equation? Yes, that's the point. You would have the same equation. If you used a14 plus b times n minus 14, you're going to get the same exact 25 plus 11n. So that's one way to do it. The other way is using point slope, something we already know. So that formula, y minus y1 equals m times x minus x1. Well, above, I already gave us points. We could use 247, or you could use this one. So you could say y minus 47. Our d is our slope, so the d here was 11 times x minus 2. And you guys should see it's almost identical to this. We have the 11 times n minus 2. Here, we're going to be adding 47 anyways, which is what they have here. So they're matching. I'm just showing you both ways you can choose to do it. 7 equals 11x minus 22, add 47, and you get 11x plus 25. They're the same equation. So it does not matter which one you use. Yeah. No. If you can do it without all the steps, you can. Just don't make mistakes. All right. You guys want to try one? Try this. Same idea. You can choose to use the left side or the right side. You choose which way you want to do. Does not matter. You can choose to use y and x's. You can choose to use a sub n. The one thing, it does want you to write it in function notation. So after you get these answers, make sure you change it. If you use this one, it would be f of n equals this. And on this side, it would be f of x equals that. So you choose whichever one. Function notation, though, has the parenthesis part. So it's the same idea here, but now it wants us to solve what term 36 is minus term 34. So let's play around with it. So when we do this, we need to find our d, or our slope, or m. So same idea. We have 317 as a point and 965. So we'll do our slope formula. I get 48 divided by 6, which is 8. So that's my d, or my m. I'll use it for d. What makes more sense? What do you guys want me to do? Point slope or the arithmetic way? Arithmetic, the new way. So then that would mean a sub n equals, we'll use 317 as our point. So it's a sub 3 plus d times n minus 3. So that would look like 17 plus our difference of 8 times n minus 3. (17 plus 8n minus 24). 17 minus 24. 8n minus 7. So now we take 36, plug it in. We take 34, plug it in, and then we subtract them. So what is S sub 36, or A sub 36? I switched it, A sub 36. When you plug 36 in for n, is it 281? Yeah, okay. When you take it, 36, you plug it in, you get 281. When you take 34 and plug it in, you get, what do you get? 265? Those that are ahead, typing in the calculator, do you get 265? Anyone? Confirm with me. when you plug in 34? 265, thank you. And then we do 281 minus 265, which is 16. Now there's a faster way to do it. What do you notice the relationship between your D, your 8, and the 16? It's doubled, right? What's 6 minus 4? Or 36 minus 34? 2. 8 times 2, 16. Watch how I apply it to this one. It's a faster way. So again, we still need to find the slope. We still need to find our difference. So 162 minus 102 divided by 14 minus 10. 60 over 4, which is 15. That's our D. So what's 5 minus 2? 3. What's 15 times 3? 45. That's your answer, 45. But if you're not sure, let's check ourselves, right? Then we do the whole equation, plug them in. So let's double check. Is it going to be 45? It is, right? Anyone that did it? Michael, did you do it already? It's 45. Thank you. So that's your fast way. You don't even have to do the equations. Let's think about why. If it's, just so you can get a better understanding, if it's, well, what did you get when you plugged in 5, Michael? Okay, S of 5 is negative 48. And then when you plugged in 2? Negative 93. So that's your second term. The third term we don't know. The fourth term we don't know, but we know the fifth term is negative 48. Here's why this works. If you know your common difference is 15 and you need to fill in to get here, plus 15, plus another 15, plus another 15. That's a difference of 45. Do you guys see that? It's a little confusing. If you don't get it, then plug gets everything in, okay? But the fast way, that's a difference of 2 times it by 2. Difference of 3 times that by 3. Your answer is 45. Okay. Now let's see a couple other topics here. Hey, Summons, who's leaving? Oh, Mohammed, you're heading home. I'll have the recording of the rest of the stuff, okay? Okay. So after today, we're going to get into graphing exponentials, something you learned last year. So we're getting a little preview, but we're using our geometric sequence. So consider this sequence. It's graphed for us here. Let's write the explicit formula, meaning that let's just write the geometric formula for that. So that A sub n equals. And that one's with the common ratio, the R. So the formula had 64, or the sequence is 64, 32, yada, yada. So we start with 64. What is it being multiplied by? 1/2 to the n minus 1. Now, pretty shortly, or actually, I'll show you the exponential function, meaning, again, use function notation for that. So it's the same stuff. And so when we do it the right side, the R here is 2. Oops, equals last. I messed that up. That should be erased. And then same thing here. So outside of this formula, another way we can see things is in this format, y equals a times b to the x, all right? That's going to be another way we're going to envision stuff. We use this formula when you don't know what your r is. So in this example, it says we have a geometric sequence with a of 2 equals 6, a of 5 equals 81 over 4. Find the ratio. We don't know r. But what we do know in this formula, where do you think, what letter do you think your r would be? B, because that's the one with the exponent. Okay? So, make sure I explain it well. My notes for myself got a little messy. Yeah. No, should I do it this way? Thinking which way to do it. My notes is all over the place. All right. So let's use this y equals ab to the x formula and think of it like this, the points again. 2, 6, and 5, 81 over 4. Yeah. Let's plug it into this formula, y equals ab to the x. Now, we know y, we know x. We don't know a and b. So what we're going to be doing is making 2 equations here. This is brand new to you guys. Nothing you've learned. I don't think you've learned this before. So I'll go ahead and do 6 equals ab to the second power. That's one of my equations. Great, so I want to make sure you're following along. And the second one would be 81 over 4 equals ab to the fifth power. So I'm just plugging it in, y and x, 2 equations. Okay. Here's how we do this. What we're going to end up doing here is dividing these because our goal is to find out what a and b are. Okay. I'm going to actually reformat it so that the higher exponent is going to be on top of when we divide. Here's what I mean. So we'll do 81 over 4 equals AB5 divided by 6 equals AB squared. So I have this long division symbol, okay? Here's why we do this. Is there any variable here that can cancel out? And what is it, Michael? You know? Not B. Well, B can simplify, but what could A? A divided by A is just 1. They can kind of cancel each other out. And then when you do b to the fifth divided by b squared, your rule of exponents is to subtract, so it's b to the third. Okay. So what we have is 81 over 4 divided by 6, right? I'm going to write this on the side real quick, divided by 6. Can you divide a fraction by a fraction? I guess you have the calculator. I don't know what it does for you. But before the calculator, what do you have to do if you're dividing? Yes, flip it. Keep change flip. 81 over 4 times 1 over 6.